Good morning, all. Today we will continue with solving problems in chapter 5. So I will start with this list of problems, and we are going to go through them one by one. So we'll start with problem 16. A 3-kilogram object is moving in a plane with its x and y coordinates given by x equals 5t squared minus 1 and y equals 3t to the power 3 plus 2, where x and y are in meters and t is in seconds. We have to find the magnitude of the net force acting on this object at the time t equals 2 seconds. So let me share with you my screen. Okay, so let's start. I'll read again the given and then write down the what we know about the particle. So we have the object has, so this is problem 16. The object has a 3 kilogram mass, so m is equal to 3 kilograms. And it is moving with both x and y coordinates, which are given by, so x is equal to 5t squared minus 1, and y, function of time, is given by 3t to the power 3 plus 2. Okay, so this is x as a function of time and y as a function of time. You have to find the magnitude of the net force acting on this object. So you have to find F at the time t equals 2 seconds. Okay, so how can you determine the force in this case? All what we know about this object are basically x as a function of time and y as a function of time and the mass. So what is the way, what is the best way, or the only way in this case to determine the force acting on the object? So if you know x and y, you can determine velocity, and then you can determine the acceleration. And if you know the mass and the acceleration, then you know, according to Newton's second law, that the net force acting on the object is equal to m times a, where m is the mass and a is the acceleration. So let's do it. So following Newton's second law, so according to Newton's second law, we know that the net force, what we call sum of external force, this is the same as when we call it the net force, that is equal to the mass multiplied by the acceleration. We know what is the mass, but we don't know what is the acceleration. However, we can determine it using x and t. So let's start. We know that x is a function of time. So x function of time is given by 5t squared minus 1. So from here we can deduce that the velocity, the x component of the velocity is the derivative of x with respect to time. So it's equal to 10t. There is no, so the derivative of 1 is equal to 0. And so we can determine that the acceleration, so from here we can determine that the acceleration ax is equal to 10. On the other side, we know that y as a function of t is equal to 3t to the power 3 plus 2. So we can determine then vy as 9t squared. And from here we can determine ay to be equal to 18 times t. Okay, so from here we can write down then, we know what are the components of the acceleration, x and y components. So here are the x and y components of the acceleration. So we can write down then a, it's nothing else than 10I plus 18t j, right? So the force F net, it's equal to m times a. So it's given by 3 multiplied by 10I plus 18t j. And so the function f net as a function of time is given by 30I plus 3 times 18 is given by 54t. So it's equal to 54 multiplied by time j. So the force F net at the time evaluated at the time t equals 2 seconds, it's given by 30 I plus 108 J. And so the magnitude of this force, F net, it's nothing else than the square root of Fx squared plus Fy squared. So it's 30 squared plus 108 squared, and this yields the value 112 in Newton. So this is the value of the force we are looking for at the time t equals 2 seconds. Okay. So let's move on with the next problem. This is F net. So the second problem, I will read the given and then we are going to write it together, okay? So I will not switch on screen every time, but I will draw everything here. So we have a bag of cement of weight 325 Newton hangs from 3 wires as suggested in this following figure. So here you have, this is the sailing, okay? Then you have 2 chords, basically the first chord and the second chord. They are different chords, okay? And then, so different cables basically. Then you have a third cable from which is attached to some support in here. And actually this support, it takes a bag of cement inside of it. Okay, so it is supporting it. The angles between the chords and the horizontal line is, so in here you have theta 1, this one is theta 2. The tension in this chord is T1, the tension in this chord is T2, and the tension in the third chord is T3. So the mass of the bag is given by, the weight of the bag is given by, so let's say weight of the bag is 325 Newton. So this bag of cement, it hangs from 3 wires as suggested in this figure. 2 of the wires makes angle theta 1 equals 60 degree and theta 2 equals 25 degree with the horizontal. If the system is in equilibrium, you have to find the tensions T1, T2, and T3 in the wires. So the system in equilibrium, when we say that the system is in equilibrium, that means that the acceleration is equal to 0. We have to find what is T1, T2, and T3 in the wires. Okay, so let's start. So here we have to discuss and analyze a little bit before to start applying the rules. So the main weight in this system is basically this bag, right? So this bag, it has a weight 325 Newton. And what really makes this bag you know, supported or in the place where it is, it's not falling down, is actually the tension in this wire, the tension T3. So T3 هي اللي عم بتعادل الويت لحتى الباج ما يوقع. بس عمليا شو اللي عم بيخلي التي 3، على شو اللي عم بيخلي هيدي الواير اللي هي معلقه بالباج اوف سيمنت هي مهديته، اللي عم بيخليها مهديته هي انه الواير 3 هي اتاتشد على 2 other wires اللي هن ال1 وال2. فاذا الحبلين اللي مدندلين من السقف، البوينت اوف انترسكشن تبعهم هون هن يلي عم بخلوا الواير تي 3 تكون مهدايه، وبالتالي بدورها هي عم بتهدي الباك. فاذا what we have to consider in this system are basically 2 things for me. The first thing is, so اول شغله هي لما ناخذ الباك اوف سيمنت نشوف شو عم بيصير عليه، لان هو الثقل عمليا يلي هو السيستم يلي عم نحكي عنه. So we have to take the bag of cement as the first object, but also we have to take this point of intersection ما بين الواير 1 وال 2 وال 3، لانه عمليا هيدا البوينت هي اللي عم بتخلي حاله الاكوليبريوم فاليد، لانه التي 1 والتي 2 هن يلي عم يحملوا الواير 3. Okay, so let's take these two, the system, which is the bag, and the point of intersection, and let's see what are the forces acting on both. Okay, so let's draw free body diagram. 4. أول شيء الباج أوف سيمنت اللي هو حأرسمه هون. So let's just draw it in here. هذا الباج أوف سيمنت right. فهذا الأوبجكت شو في عليه forces هون. هذا السبورت اللي له. Okay. هذا السبورت وهذا الباج. So we have two forces acting on this object. First of all we have the weight. حسميه W. Okay. وفي عنا on the other side the tension in the chord 3. So في عندي T3 اللي حملته من تاني جهة. Right? Now what about the intersection? Let's have a look. So the intersection حتى هون مثلها بهالنقطة هاي. Okay. على هالنقطة شو عم بيصير؟ في عنا من جهة الحبل T3 موصول بالماس. So الماس عم بتشد على هالنقطة لتحت through the T3 اللي هي التنشن in the wire. ومن ناحية تانية هالنقطة عم تنشد من جهة بالحبل الثاني ومن جهة من أو تاني جهة بالحبل الأولى. So we basically have this is T1, this is T2, and this is T3. They are all acting and exerting forces على هول الثلاثة forces موجودين على هالpoint of intersection ما بين الثلاث حبال. Okay, so let's apply Newton's second law. Now Newton's second law on the bag. خلينا ننزلها شوي لتحت بس كرمال يكون في مجال نشوف الانجلز بشكل واضح. So Newton's second law on the bag, it gives us the following. So we have W, yeah, so W plus T3 equals MA of the bag, right? But actually there is nothing here which is moving. The bag is an equilibrium, so the acceleration is equal to 0 and that is equal to 0. Let's take some axis. Let's take the y-axis pointing upward to be our reference. This is the y-axis pointing upward. And let's make the projection for W and T3. So we end up with plus T3 minus W equals 0. So T3 equals W. So already we know the first tension is equal to W واللي هي 325 Newton. So that is the first unknown. Okay. But of course we need the T3 later on لأنه T3 هي كمان موجودة على الانترسكشن اللي هي هون. So let's take it in our calculation. طيب كتير منيح. خلصنا بالنسبة للباك. خلينا نشوف شو عم بيصير هلا على الانترسكشن. So Newton's second law on the intersection on the dot. في عنا T1 plus T2 plus T3 is equal to 0 again because also the point is, this intersection point is in equilibrium. Okay, for T3 it's quite clear. It's along the vertical, but for T2 and T1 they have more than one component. One component along the vertical and another component along the horizontal. So let's take this to be the x-axis and let's take this to be the y-axis. اللي هو نفسه الأكسس اللي عنا إياه محل الثاني أخذناه بأول system. And so I just put here T3. And let me actually continue a line هون. هول اللاين هنا عمليا اللاين الموصولين بالكورد على السيلينج. اوكي. وبالتالي let me draw it correctly. So this is the line and هيدي اللاين موصول لهون. اوكي. عمليا. So هيدا الانجل هو الانجل ثيتا 1 وهون كان هيدا الانجل ثيتا 2. اللي عم بعمله بس اني عم بكمل الرسمه لحتى نشوف انا وياكم وين هن الانجل ثيتا 1 and ثيتا 2. So it's obvious I think to deduce that هيدا الانجل اللي هون هو صار الثيتا 1 والانجل اللي هون صار ثيتا 2. So البروجكشنز صاروا كثير واضحين بالنسبه لل T1 وال T2 على ال T1 وال T2 على ال X وال Y axis. Okay, so let's do it. On the dot what do we have? طيب let's say along the x-axis. Along the x-axis, what do we have? T1 هي بعكس اتجاه الx, making an angle theta 1 with x. So minus T1 cosine theta 1 plus T2 cosine theta 2, right? That is equal to 0. لأنه in both cases is equal to 0 the acceleration. And along the y-axis شو في عنا? So T1 with T2 اثنيناتهم they point out in the same positive x positive y direction. فحيطلع عندي plus T1 sine theta 1 plus T2 sine theta 2 equal we still have the T3, so minus T3 لأنه T3 pointing downward equals 0. Okay, so basically that is equal to the weight عمليا يعني عم نحكي. So we end up with a set of two equations. So this is equation number 1 and this is the equation number 2. Okay, so we are going to eliminate one of the tension in both equations, so either T1 or T2. Let's eliminate T2. So from equation 1 we can deduce that T2 is equal to T1 cosine theta 1 divided by cosine theta 2, and then we implement this into equation number 2. So بالequation number 2 بصير في عندي T1 sine theta 1 plus T2 صارت عندي T1 cosine theta 1 على cosine theta 2 multiplied by sine theta 2 minus W equal 0. W هي الweight. We know that T3 is equal to the weight. So yeah, that's all. All we have to do now is to take the same denominator for all. So شو بيطلع عندي؟ بيطلع عندي T1 sine theta 1 times cosine theta 2 plus T1 cosine theta 1 sine theta 2 minus W is equal to 0. And so فينا نقول نعمل simplification بسيطة اللي هي نحط الساين theta 1 cosine theta 2 plus cosine theta 1 sine theta 2 in factor لأنه في نفس ال T1 واحنا بحاجة إنه نجيب ال T1 أساساً. بيطلع معي هون في بس شغلة it's minus W cosine. So it's minus W cosine theta 2. This is equal to 0. So بيطلع معي that is equal to W cosine theta 2. And all what we have to do now is just to evaluate T1. So بيطلع معي إنه T1 هو عبارة عن W cosine theta 2 divided by هلا هيدي ال sine theta 1 cosine. So let me just write it down. Sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2. In the denominator, this is nothing else than sine theta 1 plus theta 2. بس مش مشكلة، ما في يعني فينا ما نكتبها. So now all we have to do is numerical application. Theta 1 is known. Theta 1 is equal to 60 degree. Theta 2 is also known as is equal to 25 degrees. And we know that the weight is equal to 325 Newton. And so by making numerical application, we end up with T1 equals, so we end up from here, T1 is equal to 296 Newton, and T2 we can deduce that is equal to, it's T1 times cosine theta 1. So it's cosine theta 1 divided by cosine theta 2. And so you can also evaluate it as, so it's 296 multiplied by cosine 60 divided by cosine 25, which is given by 163 Newton. Okay, so we have all the values now. T1 is equal to 296 Newton, T2 is equal 163 Newton, and T3 is equal to the weight 325 Newton. هو هن ال values اللي نحن كنا عم ندور عليهم T1, T2, and T3. Okay. Let's move on with a new problem. So now we are going to solve problem number 41. So a 3 kilogram block starts from rest at the top of a 30 degrees incline and slides a distance of 2 meters down the incline in 1.5 seconds. we have to find the magnitude of the acceleration of the block, the coefficient of kinetic friction between the block and the plane, the friction force acting on the block, so it's the magnitude of this friction force, and finally the speed of the block after it has slide 2 meters. Okay, so اللي قال لي هي انه موجود البلوك على inclined plane، البلين عامل 30 degree مع horizontal. البلوك عامل so it just goes down a distance of 2 meters in 1.5 seconds. We have to find its acceleration, the coefficient of kinetic friction, the friction force itself, and the speed of the block after it has slide 2 meters. So let me draw the figure. We can take the inclined plane inclined in any direction. So it could be, yeah, it could be in any way. Let's take this direction to be like that. So it could be here, it could be like this, or it could be like that. So I'll just take one of them. Let's take it to be like this. Okay, so this is the angle 30 we're talking about. Let's call this angle theta. So the angle theta is equal to 30 degrees. And then the block is sitting somewhere on this inclined plane. Okay, so let's say it's over here. So this block is moving down, of course. So this is the acceleration of the block. And what happens is that it slides a distance of d equals 2 meters in the given amount of time, t equals 1.5 seconds. Okay, the question is, what is A? So question A, what is the acceleration of the block? In part B, we have to determine the kinetic, the coefficient of kinetic friction between the block and the surface. In part C, we have to determine the kinetic friction force. And finally, we have to determine, so what was the question? The speed of the block after it has slide 2 meters. So we have to find V final, let's call it. So by final, we mean the time after it has slide 2 meters. Okay, so let's start. We need to determine first the acceleration of the block, given that the object has slide 2 meters in 1.5 seconds. Okay. Let me just draw this again, and then, so let me take, so this is the block in here, okay? The block is moving in this direction, right? So let us take the x-axis to be pointing in this direction. Let us take the x-axis to be like that. Okay, and at the moment we don't need the y-axis, but let me draw it just perpendicular to the x-axis. So this is the y-axis. And the object is moving in the same direction as the x-axis. So how can we determine the acceleration? Let me actually draw the forces acting on this block. So we have first the weight, right? This is mg. We have the normal exerted by the surface on the object. Okay. Here it is. Yeah, I'll just put them a little bit. So this is the n. This is the normal. Let's call it n. And since the object is moving downwards in this way, and we know that there is a friction force between the object and the surface, then this friction force is definitely opposing the motion. So it is in the opposite direction with respect to the motion. So this is Fk, which is the coefficient of kinetic friction. Okay, so let's analyze a little bit. We know that the mg, n, and Fk, they are all constant forces. So they do not change as a function of time. And from here, we can deduce, since the Newton's second law, it tells us that the sum of external forces is equal to ma, If the forces are not time dependent, and of course the mass does not change as a function of time, so we expect the acceleration to be a constant. And if the acceleration is constant, then we can apply the kinematic equations in this case. But what kinematic equation we need? Equations are valid, applicable, let's call it. Okay, so here we know what is x. Let's say the object has slide 2 meters. So we can actually assume that x initial is equal to 0. Suppose that it starts from our origin. We know that x final is equal to 2 meters. Okay, and we know that t, the time at the time t equals 1.5 seconds. X was equal to, so as x final equals 2 meters at the time t equals 1.5 seconds. Okay, and we need to determine the acceleration. Need to determine a. So what equation do we need? We need an equation that includes x, a, and the time. So the best option would be x as a function of time. So x as a function of time is given by x0 plus v0 t plus half a t squared. We assume that the object or the block starts sliding at the time when it was at the origin. So we suppose that x0 is equal to 0. It didn't say in the given that the block had some initial velocity, so this as well is equal to 0. And so we are left with only half a t squared. So we know that x final at the time t equals 1.5 seconds is given by 1.5 seconds. It's given by 1 over 2 a times 1.5 seconds squared, and this is equal to 2. So from here we can deduce that the acceleration is equal to 4 divided by 1.5 squared, and so the acceleration is given by 1.78 meters per second squared. So this is the acceleration that we are looking for. هذه هي قيمة الأكسلريشن. جبناها بكل بساطة using the kinematic equation. بس قبل ما نستخدم kinematic equation تأكدنا إنه acceleration is a constant. It's not moving. It's not moving. It's not changing or varying as a function of time. ما عم تتغير مع الوقت. While the object is moving down the inclined plane. Okay, the second question was شو هي coefficient of kinetic friction in UK? Okay, so whenever you are asked about the coefficient of kinetic friction, you have to keep in mind that this mu is only present as a parameter in the expression of F. يعني ما بنلاقيها غير بس بالexpression تبع force of friction, right? So we know that the kinetic friction force Fk is equal to mu k times n. Okay, so from here, this is the only way to access mu k. Mu k is equal to Fk divided by the normal n. We don't know what is Fk and we don't know what is n. So we have to get the expressions of both F, the friction force, and n, the normal. So let's actually make our projection. So Newton's second law on the block. We know that we have the normal plus mg plus the force of kinetic friction equals ma. Okay, so let's now make just the projection. So we have two projection along the x-axis and projection along the y-axis. So along the x-axis طيب لحتى سهل على حالنا المهم خليني ارسم هون ارجع مرة تانية الرسمة. So what happens is the following. هون هي البوينت اللي عندنا اياها. Let me draw it in here before. So هذا الاوبجكت رح مثله بنقطة. هي النقطة. Okay. And the forces acting on this block are the following. So we have هيدا الMG, هيدا النورمال, هيدا الFK. هيدا النورمال M. Okay. هيدا الX axis, هيدا الواي اكسس هون. This is the y axis. This is n. Okay. And what we still have to determine هو الانجل ما بين الام جي، لانه الام جي الام جي هي الفورس الوحيده اللي منا لا على الاكس ولا على الواي، هي موجوده على الاثنين، يعني عندها projection على الاثنين الاكس والواي. So let me just draw the angle correctly and so we can do it. Voilà. So again, the angle between mg and the vertical، هون عمليا في عندنا تقريبا في عندنا هيدي الهوريزونتال، وهذا الانجل ثيتا هو الانجل ما بين الفورس ما بين الانكلاين بلين وما بين الهوريزونتال. اوكي. سو طلعوا على هالرسمه اللاين الاخضر والهوريزونتال في بيناتهم انجل ثيتا. الواي اكسس هو perpendicular على الاكس اكسس اللي هو اثنيناتهم بالاخضر. اوكي. واذا بناخذ لاين ثاني perpendicular على هذا الهوريزونتال اللي هي هون داش لاين اللي هي الام جي، actually بنقدر نقول انه هذا الانجل ما بين الام جي والvertical axis هو نفسه. Okay, let me draw again this. This is the x-axis. So this is n. This is here mg, and this is fk. So the angle between هالاثنين لاين اللي هن الاكس والهوريزونتال هو نفسه ما بين الواي والام جي، لانه الام جي perpendicular على الهوريزونتال والواي perpendicular على الاكس. So this is the angle theta. And if we make the projection of mg along this vertical and along the horizontal axis, we will end up with, so على الvertical تطلع معي هي mg cosine theta، وعلى الهوريزونتال تطلع معنا mg ساين ثيتا. سو هلا صار في عندي كل الفورسز على الاكس والواي اكسس، كل شيء عندي اياه او كل شيء هلا بحاجه له اني اعمل بس طبق نيوتن سكند لو and make the projection along the x and along the y axis. So let's do it. Okay, along x شو بيطلع عنا؟ بيطلع عنا plus mg sin theta minus fk، لأنه ال fk بعكسها هي equal ل ma لأنه ال a نازل نزول البلوك، so ال a عندها positive sign. وبالنسبة للواي axis so في عندنا plus n minus mg cosine theta equals لزيرو، لأنه بكل بساطة there is no motion along the y axis. Okay, that's it. So from the first one we can deduce that, from here we can deduce that fk is equal to mg sine theta minus ma. So m, let's put it in fact g sine theta minus a. ومن الثاني بنقدر نستنتج انه n هي عبارة عن mg cosine theta. And don't forget what we want to evaluate in this section is mu a. So mu k is given by fk divided by n, so it's equal to mg sine theta minus a divided by mg cosine theta. So إذا بس نجي بنقسمهم على بعضهم بيطلع معي it's tangent theta minus a divided by g times cosine theta. So this is what we end up with, and so this gives the value طلع معنا so it's 0.368. This is the value of mu k. And don't forget that for mu k there is no unit, because mu k is the ratio between two forces. It's the friction force divided by the normal force, and the friction force is expressed in Newton, and the normal force is also expressed in Newton. So بالنتيجة mu k هي من دون أي unit. It's just a number that is smaller than 1. طيب this is for part B جبنا ال mu k. For part C بدنا نجيب ال fk. I think now fk is quite obvious how we can calculate it. So fk is given by m factor g sine theta minus a. ال a جبناها بأول part. ال m والساين والثeta والg معنا إياهم. So بيطلع معي the value. You just have to make the numerical application, and you end up with 9.37 Newton. Finally, you have to determine in the last section what is the velocity of the block, what is the speed of the block after it has slid 2 meters. Okay, so how much is the velocity? بالحالة العامة لما إذا كان عندكم شو هي الأكسلريشن أو إذا عندكم البوزيشن تقدروا تجيبوا من خلالها الفيلوسيتي. هلا بهالحالة نحن كل شيء بنعرفه هو إنه الأكسلريشن is constant. ف we can apply the kinematic equations and we know what is x. X is equal to half at squared. So actually we can, since we can apply the kinematic equations, we need an equation where it includes v and it includes x, right? لأنه أنا بعرف إنه هو مشي مترين، okay، وبدي أجيب velocity بعد ما يكون قطع مترين. So how much is it? We can use the equation v as a function of x, which is given by v squared minus v0 squared equals 2a x minus x0. Right? You remember this equation. We know that, so on one side x minus x0 هي المسافة اللي قطعها على inclined plane اللي هي 2 meters. Okay, we know what is the acceleration. This is equal to 1.78 meters per second squared. طبعا ال 2 هي just a factor. And v0 squared, v0 هي عبارة عن صفر. نحن بنعرف إنه هو مشي initially it did not have any initial velocity, so we end up with v squared equals 2 times 1.75 times 2, and so we can deduce that this is v final squared, and so v final is equal to square root of this value, so it's square root of the value of this is 7.11, and so square root of 7.11 is 2.67 meters per second. So this is the value of v final. This is v final. Okay, so that's it for this part, for this question, and as well for this problem. So let's move to a new problem. Problem 44. 3 objects are connected on the table as shown in this figure. The table is rough and has a coefficient of kinetic friction of 0.35. The objects have masses of 4, 1, and 2 kilograms. So مثل ما أننا شايفين من أول جهة في عنا 4 بعدين بالنص على التيبل في عنا 1 kilogram وفي عنا 2 kilograms on the other side. And the pulleys, they are frictionless. We have to draw free body diagrams of each of the objects and then determine the acceleration of each object and their directions. Finally, we have to determine the tensions in the 2 chords. So here it says clearly إنه من أول جهة في عنا chord ومن تاني جهة في عنا chord تاني. لما يقول in the 2 chords يعني هول chords مختلفين عن بعضهم. And لما نحكي عن 2 chords مختلفين عن بعضهم يعني عم نحكي عن tension مختلفين عن بعضهم. نحن قلنا بالكور لما كنا عم نحكي عن chapter 5 إنه whenever you are dealing with a given chord that is attaching two objects, إذا كانت مارقة فوق pulley مثلا مثل بهالحالة هون, this pulley is frictionless وعادة بناخد ال pulleys as massless as well. The tension in the chord does not change لأنه التنشن من أول جهة من البولي هي نفسها على تاني جهة من البولي بما إنه البولي is frictionless and massless. So لهالسبب التنشن in the chord بتضلها هي ذاتها, يعني التنشن اللي فيها عم ينشد هيدا الأوبجكت اللي هو 1 كيلوغرام هي equal للتنشن in the chord اللي عم ينشد فيها الأوبجكت اللي هو هون 4 كيلوغرام. ولكن لما يكون عم نحكي عن 2 chords مختلفين ساعتها عم نحكي عن tensions مختلفين لأنه ما في ولا أي سبب لتكون التنشن in this chord هي نفسها التنشن in the other chord. Okay, so let's solve the problem. I will move again to the whiteboard. Okay, so let's move on. I'll write the given again and read it with you. So this is the problem 44. We have, this is the table. هاي التيبل اللي عنا إياها. Okay. على هالتيبل موجودة من جهة في عنا. So this is the first pulley and this is here in the second pulley. Okay. And these pulleys, they are related to some connected, يعني connected to some mass here that is equal to 1 kilogram. وبعدين من كل جهة في عنا block. So في عنا هون block وفي عنا هون كمان block. Okay, so let me call them some M1, M2, M3 بهالشكل بصير نسهل على حالنا الشغل. So let's call this one M1, okay? Let's call the second one اللي هو بالنص M2 ونحكي عن هيدا as M3. Okay, we know that M1 is equal to 4 kilograms. M2 هو عبارة عن so M2 was equal to 1 and M3 equals to 2. Okay. Now let's discuss a little bit how the system will move. ال M1 هي الأكبر شيء، هيدي هي ال 4 كيلوغرام، هيدي ال 1 كيلوغرام وهيدي 2 كيلوغرام. So طبعا إذا بدنا نحكي المنطق الرسمي لازم يكون هيدا أكبر بعد. So this is the 2 kilogram. Okay. So عمليا اللي حيصير إنه ال M1 هو اللي حيشد السيستم لأنه هو أتقل شيء. So ال M1 will move with an acceleration. Sorry. So it will move in this direction. Let's just draw the direction of motion. So ال M1 حتنزل نزول حتكون عم بتشد بهالاتجاه لأنه هي الأتقل. This is A1. Now this one is A2. ال M2 حتمشي ب acceleration A2 وال M3 بهالحالة حتطلع and this is A3. So this is A3. Okay, so let's draw in the given, we are asked to draw the free body diagrams of each of the objects, and we have to determine the acceleration of each one and their direction. So we already determined the direction of the acceleration. Let's now draw the free body diagram on each object and then apply Newton's second law. So I will just put it aside. خلينا نكتبهم هون. So the free body diagrams for each of these blocks. So for M1, okay, رح ارسمهم مثل ما هن، رح حطهم بهالشكل، يعني رح ارسم البلوك وبعدين حط عليه الفورسز. So as you know, we have the weight on one side which is M1G and we have the tension in the cord. بما هون في عنا 2 كورد، خلينا نسمي هاي الكورد أول وحدة رح حط عليها T1، خلينا نسمي هيدي الكورد 1 يعني، والكورد الثاني هي 2. So هيدي حتكون عليها T1. اوكي، بالنسبة لل M2 اللي هو هون this is for M2. اوكي، كمان M2 بنفس الطريقة. So we have M2G acting on the block and we have the tension in the cord, but هون صارت بالسكند كورد عم نحكي، صار رح حط T2 والكونكشن ما بين اثنين بلوك هي اللي بالنص صار ال M1 ال M2. Pardon, so wait, this is M3, this is M3 وهون بالنص هو ال M2. So على البلوك 1 في عنا الويت M1G وفي عنا tension of the first chord اللي هي T1. بالنسبة للبلوك M3 في عنا ال M2 M3G. Let me just correct this again. So عن جديد بالنسبة للبلوك M3 اللي هو هون على الطرف الثاني في عنا ال M3G هي الويت تبع هالبلوك، وفي عنا tension in the second chord رح سميها T2 لحتى اعمل لها differentiation مع اول chord. So عم نحكي عن الكورد الثاني. اما بالنسبه لل M2 فصار في عنا كذا فورس هلا هون بهالحال. So اول شيء في عنا ال M2G اللي هو بالنص هذا البلوك، وفي عنا النورمال exerted by the table on the block لانه هذا البلوك عامل كونتاكت مع التيبل. في عنا من اول جهه هذا البلوك is attached على ال M1 so في tension in the cord T1. من ثاني جهه كمان هو connected على ال M3 so في عنا tension بثاني كورد اللي هي T2. وغير كل هيدول ما ننسى انه هالاوبجكت اللي هو البلوك 2 is sitting on the table وفي عندكم friction force على التيبل. اوكي، طيب البلوك 2 كيف عم يمشي؟ عم يمشي باتجاه اليمين، باتجاه شمال، من اليمين يعني للشمال. So that means إنه في عنا force friction F, it should be opposing هالmotion. Donc the friction force it should be pointing to the left بالاتجاه اللي حطيته اللي هو الاتجاه الأخضر. وهيدي ال A2 بس كتبتها هون رجعت بالأخضر لحتى أقول إنه إذا البلوك ماشي بهالاتجاه معناتها الفريكشن فورس عم بتعارض عم بتقاوم حركته. So these are the three blocks with all the forces acting on the blocks. Now all we have to do is to apply Newton's second law. So let's apply Newton's second law on the three blocks M1, M2 and M3. خلينا نبلش بالأول. And we have definitely to take some X and Y system. So خلينا ناخد مثل ما بناخد بالعادة conventionally X to the left and Y upward. So we end up with من أول خلينا أذكركم كمان بما إنه هيك عم نحكي عن البلوكات. So هذا ال M1 نازل نزول, this is A1. ال M3 طالع لفوق, فإذا this is A3. So ال M3 طالع لفوق, فإذا هو ماشي ب A3. Okay, I'll draw it on this side. So هيدا ال A3. Okay, let's start. So we have on the first block على البلوك M1 في عندي plus T1 minus M1G equals minus M1A. Of course, here we have A1 and A2 and A3, which are different in direction. But at the end of the day, the modulus, the magnitude of the acceleration is the same because the chords are inextensible. So ما بيشدوا, ما فيهم elasticity. وبالتالي قد ما كل البلوك ثلاثتهم عم يمشوا قد بعضهم. يعني إذا البلوك M1 تحرك given إذا هذا البلوك M1 تحرك had distance that you can call it D. اوكي, الM2 كمان عم يتحرك نفس الشيء D بس on the horizontal, والM3 عم يتحرك D on the vertical. So ثلاثتهم عم يمشوا بنفس القيمة, وبالتالي ثلاثتهم عندهم نفس الاكسلريشن. So for M1 this is it. I will go to M3 immediately. So on M3 لأنه ما فيها غير projection وحدة, كمان we have T2 minus M3G is equal to plus M3A لأنه بهالحالة M1 طالع لفوق. And finally on the block M2 شو عم بيصير؟ So ما في عندي two projections. أول projection في عندي إياها minus T1 plus T2 plus FK is equal to minus M2A لأنه ال M2 عم يتحرك بعكس اتجاه ال X axis, right? And we have on the this is along the X, so along projection along the X axis, and projection along the Y axis it's very easy. So we have plus N minus M2G equals 0 for the simple reason that the block M2 has no motion along the Y axis. So at the end of the day we end up with three equations. أول equation بتبقى مثل ما هي on M1 on M3. بالنسبة لل M2 بنقدر نجمع هون اثنين equation بequation وحدة بشكل so it's minus T1 plus T2 plus ال FK هي عبارة عن mu K times N, so it's mu K times N اللي هي M2G that is equal to minus M2A. So what? This is the equation number 1. This is equation number 2. And this is equation number 3. So this is 1, 2, and 3. So all what you need to do now is to solve the simultaneous equations. So you have three simultaneous equations with two, with basically actually two unknown, three unknown. So we have T1, T2, and we have as well the A. So all what we need to do is to eliminate T1 and T2 to get A, or eliminate A to get T1 and then T2, etc. So I will give you the answers. So for the answers we have the equations are أول وحدة هي T1 minus M1G هي 39.2 is equal to 4A. بعدين عطينا equation بتاعتينا minus T1 so تاني وحدة هي minus T1 شو بتطلع معي plus T1 minus T2 plus ال UK M2G صارت في عنا 0.35 times 9.8 Newton. So plus, let me just write it down, 0.35 times 9.8, okay, is equal to M2A, so it's equal to 1 multiplied by A. وبالأخير ثالث وحدة حتعطيني plus T2 minus ال M3G هي 19.6 Newton equals 2 times A. So when 1 times A يعني هي عمليا A. So we end up with these three equations. Okay. Now let's actually, if you add them up, we end with, so part A, adding the three equations. We end up with, so بيطلع معي 2 yeah. إذا جمعناهم لازم بدهم يصيروا T1 and T2 بس هون بيطلع معي 2 T1. So مثل ما انتم شايفين هون إذا جمعناهم الماينس T2 من هون مع الماينس مع T2 من هون بتصيروا مع بعضهم. So T2 بنخلص منها بس بيبقى still عندي T1, but T1 also should disappear. Let me check. Okay, so here we have T1 minus 39.2 is equal to minus 4A. فخلينا نضربها كلها ب minus 1 بتصير minus T1 plus 32 is equal to plus 4A. So بهالحالة إذا بجمعهم ثلاثتهم بيطلعوا معي بالشكل التالي minus T1 plus 39.2 okay بتصير plus تاني equation بتعطيني T1 minus T2 plus 0.35 multiplied by 9.8 هي 3.43 okay plus ثالث وحدة T2 minus 19.6. So this is the first equation. Second equation, third equation is given by 4 plus 1 plus 6 تعطيني 7A. 7A. So now have a look. Minus T1 plus T1, they cancel each other. Minus T2 plus T2, they cancel each other. So we are only left with two numbers. هي عمليا 39.6 plus 3.43 minus 19.6 equals 7A. So we can actually deduce that the acceleration A is equal to 2.31 meters per second squared. Okay, and so this acceleration in magnitude, it's given equal to this. Now in direction, it is down 4m1 اللي هي equal ل 4 kilogram. بالنسبة لل m2 هي to the left, so left يعني مثل ما رسمناهم على الرسمة equals 1 kilogram and it is upwards for m3 which is equal to 2 kilograms. So عمليا مثل ما رسمناهم على الرسمة لأنه مثل ما انكم شايفين هون طلعنا المودولس of A الماجنت طلعت positive. يعني مثل ما أخذنا نحن البروجكشن لل A على الإكس والواي أكسس كانت 100% صحيحة وبالتالي we can confirm that M1, M2 and M3 they are moving just like we draw them. هيدا التيبل اللي موجود عليها السيستم. So as we have drawn them, the A1 عم تنزل نزول, it's moving down. So this is A1 again. The A2 is moving to the left. The M2 طبعا يعني وال A3 is pointing upwards يعني the M3 is moving upwards. Okay. So this is it. Now we have determined what are the accelerations, the vector acceleration and the modulus or the magnitude of the acceleration for the three blocks. The other question was, this was part A. Now in part B, we have to determine the tensions in the two chords. So in the second part, we have to determine both T1 and T2. So this becomes actually now a detail. هلا صار تفصيل لأنه صار في عنا كل شيء نقدر نجيب من خلاله ال T. إذا بتاخذوا هيدا الإيكويشن number 3. Equation number 3, T2 minus 19.6 is equal to 2A. So we know that T2 minus 19.6 is equal to 2A. فمن هون بنقدر نستنتج قيمة T2 which we will If you calculate it, you will end up with 24.2 Newton. Okay, so this is the value of T2 and the value of T1. So بطلع معي T1 في اخذ الايكويشن في equation ما فيها غير بس T1 اللي هي اول equation. So باخذ minus T1 كان عندنا minus T1 plus 39.2 equals 4A. فمن هون نقدر نستنتج انه T1 is equal to 30 Newton. بطلع معنا 30 Newton. Okay. So these are the tension in the two chords. ومثل ما نكون شايفين طلعت معنا فعلا ال T1 مختلفة عن ال T2 لأنه the two chords they are different. So what you have here in the first so هون اللي بيطلع معكم as tension بهيدي الكورد tension بهالكورد هي نفسها وهالتنشن مختلفة عن التنشن بالكورد الثاني. So this is if you call this to be T1 هيدي قيمتها كمان T1 فإذا بالكورد الثاني صارت T2 كمان اللي عم تعمل اكشن على الام 3 هي تي 2 مثل ما حكينا باول البروبلم. So let's continue with problem 54. You have this figure. In this figure you have three blocks which are in contact, M1 and M2 and M3, which have different masses. So they are in contact with each other on a frictionless horizontal surface. So there is no friction between neither of these blocks and the surface. A horizontal force F is applied to M1. So it's only applied to M1, but it let the system move. If you take M1 to be equal to 2, M2 3, and M3 4 kilograms, and F is equal to 18 Newton, we have to draw a separate free body diagram on each for each block, and we have to find the acceleration of the blocks, the resultant force on each block, and we have to find the magnitudes of the contact forces between the blocks. Okay, so I'll just take the parts A, B, and C. So in part A, we have to find the acceleration of the blocks, then the resultant force on each block. So for each M1, M2, and M3, we have to see what is the total force acting on it, and finally we have to find the magnitudes of the contact force between the blocks. So let's solve it. Let me share again my whiteboard.